geometrically. Now, this is just one of our stress profile. Then we have another profile coming in, and the next profile will be our bending moment. Okay, so again, this is my stress X, and then this is our Y distance. Right, and then we're gonna I'm going to follow what's up there. The alpha is in compression, then tension. So we know that we have this profile for distribution. Right, so at the top will be compression, at the bottom will be tension. By right, I should also draw the first one. I should stop down there so it's clearer where we stop the stresses. Okay, so we stop. Right, so the next one, the stress X is equal to my over I. Okay, so now this is due to bending moment, right? This is due to bending moment. So at the top, we have compression. So it's pushing towards the material. And at the bottom is in what? Tension. Okay. So now, if we were to sum both of them, if we were to add both of them, you realize that the stress profile will be what? Will be shifted. Okay. The stress profile will be shifted. Okay. So the stress profile now looks like this now. So this is our stress profile. So again, this is our stress X. This is our Y. And because of how it is our stresses are distributed, now this is how our profile will look like now. Okay, so now our profile will look like this. So there will be a shift towards the right. So what we see at above here, this will be in compression, and then below that, this will be in tension. Now, if we look relative to X now, relative to the Y-axis, over here, this is the position of the centroid, right? This is the position of the centroid, right? Now, because of eccentric loading, what happened now is over here, that I'm drawing in pink now, this is now the position of the neutral axis. Neutral axis means the stress must be equal to what? The stress must be equal to 0. So you see a shift now, okay? And this is only true if this is only true when you have eccentric, okay, eccentric symmetrical loading. Okay, when you have eccentric symmetrical loading, the centroid, right? The centroid axis is not equal to the centroid axis location is not the same as the what? Neutral axis. Okay, because there's a what? There's a shift. If it's just centric loading, so if we just look at this diagram alone, okay, we just look at this diagram alone, right? We just look at this diagram alone, and if there's no axial loading And if it's based on that diagram alone, now we have what? Now, with this bending alone, is what we call centric, right? Symmetrical bending. When that's the case, for if we just focus on this diagram over here, when that's the case, the position of the neutral axis and the position of the centroid is exactly the same. But when it comes to eccentric, there'll be a shift. Okay. So far, anyone have any questions, please? If you are not clear, I can elaborate anything. Anyone? We're okay? We're okay?
Yeah, you're good.
Okay, we are good. Thank you for that response. Right. So what I'll do now, so now the thing, let's copy this diagram again. Okay, I want to copy this diagram. Then we're going to paste. Now, what if now, okay, I want you all to like visualize, okay? What if now?
You're muted again.
Can you hear me again?
Yes. You're just at what if now?
Okay, yeah, I think something is controlling my computer. And this wasn't me, okay? Thank you for letting me know. Right, now, coming to here again, so what we are going to do now, okay, I want you to think for a bit now. What if now we were to change direction? And now we were to change direction, and this is my P now. Okay, now this direction, this is my P. I mean, exactly acting at A. Now this is my P now, right? What will happen now? So if this is my P, right, we flip the direction of the P now. Okay, we flip the direction. Now the direction of the P just gone what? Opposite. So what's going to happen, right? What's going to happen is this. Newton's third law on the axial load. If there's the P is flipped, we know that this is the actual direction, okay, of our Px. Yes or no? Action equal to reaction, same in magnitude, different direction. And then now the moment will act this way now. Right? So again, everything will what? Will flip. Okay, again, the head of the moment arrow, now this will be what? Compression. And over here will be in what? Tensile mode. Okay, so it's at point C that where the structure will fail. Again, I'm going to call this alpha, and I'm going to call this beta. So if we now were to write out the formula, now what we had, stress X at point alpha, now it will be equal to minus Px over A, right? And then at point alpha, it's in tension, plus by mz over izz multiplied by y. And then your stress X at point beta now becomes minus Px over A minus by mz over izz multiplied by y. Does that make sense now? Okay. Now, I want you to make a guess based on your experience. Can anyone tell me which is higher? Okay. What do I mean? Hold on. What do I mean by which is higher? Can anyone tell me in terms of magnitude? Is the axial load higher in magnitude, or is it the moment higher in magnitude? Anyone, please. Which one will have a higher magnitude? Based on your experience, anyone, please. No? Note
The moment.
takers. The what? Hello?
The moment.
The moment. Why? You're right.
Because you're
Yep.
multiplying by an additional term.
Say it again.
Because you have the lever arm, and you're multiplying by an additional term.
Okay, you are absolutely right down there. So what I'm going to do now, I'm going to do a demo. Okay, I'm going to stop sharing, and I'm going to turn on my video. Yeah, I don't know whether can you see me. Some of you can see me.
Yeah, we can see.
Yeah.
Okay, sorry about that. Right. So I have anger management issue. Okay, this is my ruler, right? So if I'm going to break the ruler, right, I put in tension, it's not going to what? It's not going to break. So what's the next thing that we do? Anyone? You tend to do this, yes or no? And when you bend, it will actually what? Breaks. In tension, it will break, but you need a lot of force. Okay, I'm not Dr. Wall. Dr. Wall is much stronger than me. Okay, so for me to break this ruler, I have to induce what? Bending. Right? When I bend, it's really easy for me to break the ruler. Okay, so that's exactly what a student said just now. Sorry, I did not get your name earlier. I do apologize. Okay, but he's absolutely right. Right, so I'm going to show you my screen again. Right. So we know that over here, so we know that MZ over IZZ Y is always going to be greater than PX over A. And this is always true. I try to see, have I seen it otherwise? No, I've never seen it otherwise. Okay. So what you have learned down here is I teach you how to flip the forces around and how to look at reaction. So now this is important. A lot of times even me tend to forget that the translation of the force over here have a what? Have an axial load. Okay, a lot of times I forget to do that. Okay, so don't be like me to be so forgetful, because later on when you come to look at a structure like this, okay, especially the 100 kilonewton over here, it's not just inducing a moment, but it's also inducing a what? An axial loading of also 100 kilonewton at the centroid. Okay, so if you miss that out, your entire stress analysis will go down the window and it's a waste of time. So do not forget that. Okay, so now let's go on to, so any more I need to inform you, you guys know. So what we have done so far is we have looked at the theory, right? We now look at the stress profile. We have looked at the stress profile, how it looks like. Okay. Next, I'm going to go into the example. So the example, we also will find from this example, I want you to learn how to find the actual position of the neutral axis. Okay, and there's formula involved. I tend to avoid those formula. I want to do simple for you guys. Okay, now let's look onto the example now. Okay, we're going to look at example number 1. So example number 1, which I'm going to copy the question now. So is this example that we're going to look at? Right. So knowing that the clamp shown has been tightened on wood planks being glued together until P is equal to 400 newtons. So from here we know that P 400 newton, right? Determine on the section AA the stress point at A. So we want to find the stress point at A, the stress point at D, and the position of the what? Of the neutral axis. Okay. So we're going to calculate the stresses, and we're going to look at the location. And I'll go further is we are also going to find we're going to also sketch the stress profile. Okay. So from here, we realize that the